Logarithmic functions and graphs. Objective, you can use the definition of logarithms to help solve exponential problems. So logarithmic functions are the inverse functions of exponential functions. Find the inverse function of the following exponential function. Y equals 10 to the x, and if you remember, you change the x and y. So it would be x equals 10 to the y power. But one of the things that we have is that this isn't enough when it comes to logarithms. We need to actually change it around so that we get x equals log base 10 of y. So if you switch these places, this becomes your base, and then you put log there with it. And this is read the logarithm base 10 of x, which means the power to which we raise 10 to get to x. Okay. So from this one here, logarithmic function base a, we define y equals log base a of x as the number y such that x equals a to the y, where x is greater than 0 and a is a positive constant other than 1. So log base a of x equals y is the same as x equals a to the y. Now this is an important idea. Base 10, it's the same as this one. These are considered common logs. So again, the base 10, our calculator is base 10. Most of what we do is base 10. So the next problems are asking us to find each of the following. Do not use a calculator. So if we rewrote it back into the other format, it's going to be 3 to what power will give us 9. And we know 3 squared is 9, so x would have to be 2. This one, log base 10 of 10, it's 10 to what power gave us 10 to the 8/5. A little obvious there, x equals 8 to the 5th, because they already have the same base. The next one, 10 to what power gave us 100. And then we can look at this going, well, 10 squared is 100, so x would have to be 2. And then we're going to change this guy to be 2 to the 1/2 power. So then we're going 2 to what power gave us 2 to the 1/2 power. And it would have to be x equals 1/2. We'll get more in detail with these, but these should be obvious ones. You'd have to change it back to this format, but this is the base, this is the value. What did I raise this base to? What power did I raise it to? So let's put that one in words. This one specifically. 3 to what power equals 9? Same here. 10 to what power equals 10 to the 8/5. 10 to what power will give me 100, so on and so forth. Those are common logs, natural logs. Logarithms base E are called natural logs. The abbreviation ln is generally used for natural logs. A lot of people will just say ln of x instead of natural log of x. So this is log base E. Now here's one thing to notice. Natural log, always base E. This one, logs, the base can be any value. And hence, that's why it is called common log, because I can change this base to fit whatever purpose I'm using. This one is very much used in the scientific world, always base E. So these next problems, same thing. Find each of the following. Do not use a calculator. Natural log of E. E to what power gives me E, because remember the base is E. E to what power gives me E? Well, that would have to be the power of 1. e to what power gives me 1. Well, remember, anything to the 0 power is 1, so that would have to be 0. This is true no matter what the base is. Log of 1, always 0. And then e to what power equals e to the negative 5th. X would have to be negative 5th. Negative 5, sorry. So I don't want to say these are going to be common, but they do kind of fall into place there for the common. Okay, another idea on logarithms. Log base a of x equals y is the same as x equals a to the y. So you're going to be asked to convert between both of these at all times. But notice on this one, x equals a to the y. Basically, you just take this guy out and change places with these two. This is always going to be your base. This is always your exponent. So on this one here, base equals 5, exponent is negative 3. So this is going to be log base 5 of 1 over 125 equals negative 3. Okay, this one, base is e, so we'll use natural log. And your exponent is negative 1. So the natural log of 0.3679 equals negative 1. Okay. And a few more. So still the same idea. So there we did, this page we went from exponential to logarithm, logarithm to exponential. Still, base equals 4, exponent is t, so it's 4 to the t power equals 7. This one, base e, this is my exponent, so it's e to the negative 0.9676 equals 0.38. Again, base equals t. This is my exponent. So t to the k power equals q. Okay, you've got to be able to go back and forth on these. Okay, on this one, I use a calculator. Your log button on your calculator. Let me verify where it is. Log button is by the 7. So you would just, it would be 7. The calculator is in base 10. And then type in the 93100. Do not put in a comma. And hit enter. So nine three one zero gives us a number of 4.96894. We should always go at least 4 decimal places. Oh, it even says that, 4 decimal places. And then your natural log is right by actual log button. I was writing what it was next to, is by the 4 button. ln, and then type in your numbers 0.00037. Gives us negative 7.90200. If you round it, right? Listen, that's more than I needed. So, yeah. And there you guys go. The calculated part should be by far, obviously, the easy part. Okay, so this is where we're going to stop with day one. Start your assignment, 1 through 67, every other odd. Most of it is either translate, is very, very little math I want you guys to find. 1 through 67. Well, first of all, if you divide it in half, you'd have all the odds. And so that would get you to what? 34. So there's about 17 problems. You can handle it. Okay, good luck.